Now, if you want to get a little bit more fine-grained, you can provide hints to the linker through two mechanisms: attributes applied in your code and a linker directive file, which is written in XML and provided to the linker during the compile process. Well, let's look at both of these. The first approach is to go through your class and add a preserve attribute to types that you know you need. And this is what has been done to critical types in the SDK assemblies. The linker interprets this attribute to mean the type must always be included. Now, when you apply it to a class, you can also set a property all members to have it preserve not only the type, but all the fields, all the methods, and all the properties. Now, if you want to preserve the entire assembly, maybe it's a core data assembly, you can simply put the attribute on the assembly itself, as shown here. Now, if it's just a specific field, a specific property, or a specific method, you can just put the preserve attribute right on the definition itself. So as an example, here we might not be referencing ID in our code directly, but we still want that field to be created in the database and therefore want it in the class definition. Probably a good idea. Now, it's very likely that you're using a PCL or a shared asset project to hold your shared business logic. So the preserve attribute is actually part of the core Xamarin assembly. And it's actually unavailable to portable class libraries, but it is available to those shared asset projects. So to allow you to use this in PCLs, the linker specifically looks for this attribute by name only. Now that means that you can define your own PCL version of the attribute as shown here, and then apply it to your classes and members, and the linker will respect it. Now the namespace is not important. The linker simply looks at the name of the attribute. Now, all members, which you saw earlier, it's used when the attribute is applied to the type itself, and conditional, this allows you to say, keep a member only if the type itself will be kept because of a direct dependency. Now, our second approach is to create a linker configuration file. This is an XML file that you'll add to your project, and this lists the specific assemblies, types, and operations that you want the linker to ignore, and again, ensure they're kept in the final produced binary. Keep in mind that you only need to list things you don't actively reference but want to keep. So hard references to methods and types in your code will always be preserved. Now, to use the linker XML file, you add it to your project as an XML file and then set the build action to be link description. Now, the format of this file is well defined and allows you to take as much control of the process as necessary. And it always has a root tag of linker and a set of assembly children. Now in the assembly section, you can specify a full name or partial name for each assembly that you add to this file. So here we're telling the linker to keep the app.core assembly, and this will match any assembly by that name. Now within the assembly tag, you'll list the types to keep, or as you can see here, you can tell it to keep all types through a wildcard. You can also add type tags for specific types. For example, here we want to keep the main page type in the app core assembly. Now, an optional attribute on the type tag tells the linker to preserve every field in the type, and by default, it will preserve all operations since none are listed. And you can preserve types through the namespaces that they're defined in, and this keeps every type declared in the specified namespace. And finally, you can be very specific about the operations using the method and field tags. So if you have an overloaded method, you can specify the signature instead of the name. And again, you can see that here on screen. Now, going through the steps to reduce the size of your assemblies can have a dramatic impact on your app package, and it's highly recommended that you go through these steps, especially for larger applications. But it can be a little bit tedious. So here's just a workflow to follow. Remember, this is for the release build, and if it's an iOS app, make sure to use a real device for testing and use the iPhone configuration so it compiles the app to native code without jitting. With Android, you can use an emulator as long as it executes the same code as the real device. So, set your linker options, so to include all assemblies. Create a linker XML file, add it to your project, specify that the linker should preserve all of your assemblies, and then use the references in the solution to know what assemblies to add to the file. And then add a global type inclusion so the linker preserves everything in each assembly. Now, run your app on a device and test all aspects to make sure nothing is missing. And it should work because we're not throwing anything out. So if you're hitting a bug, there might be a bug in your code. It's probably not from the linker. Now, remove one assembly from your linker file so it's included by the linker. This will dump everything out of that assembly that you don't directly use. Now, run the test again. It's helpful to do this in the debugger so you can see exceptions, but the iOS diagnostic log and Android debug log will show exceptions as well. Now, if you're lucky, everything continues to work. But if the linker got a little bit too aggressive, you'll get a runtime crash. Now, most often, this will either be a type initialization exception, because it threw an entire type away, or a missing method exception, because it got rid of a called operation. So now you want to identify that missing type or operation and then add it to your linker configuration. And then, of course, we're going to repeat that process until you've gone through all of your assemblies and your app continues to run as expected. Now, once you've got a compacted application, you're ready to create a distribution package. Now, these are often zipped containers with your application and all of its assets. Now, each platform does this a little bit differently, and really the best way to stay up to date is to check the documentation from each vendor. There are also excellent guides on developer.xamarin.com.